In the previous video, we described an experiment that was checking to see whether an online or a classroom prep course would be more effective in preparing students for the SAT. So here are the results of this experiment, and with the dot plot showing this. So the students who took the online course showed this much improvement in their SAT scores, and then the classroom, people who are in classroom, showed this much improvement. And so I made a graph, and notice that the graph has to have certain characteristics. It needs to be labeled so that we know exactly what it means. So this is the number of points improvement in SAT. This is the online group, this is the classroom group, and then we have the scale here. Notice the scale has to be identical for both so that we can adequately compare them. Now when we look at the comparison, we see that there seems to be a slight improvement in a slight difference in that the online course seems to improve the scores a little bit more, but there's a lot of variation in both and not a huge amount of difference. So it's kind of not sure if this is enough to be statistically significant or not. It turns out, though, we have a source of variation that's causing a problem. It turns out that among the 20 volunteers, 10 of them are in pre-calculus, 6 are in algebra 2, and 4 in geometry. So this contributes to a lot of variability in the score. So how can we address this problem? Let's separate and compare within each math level. So if we just compare pre-calculus to pre-calculus, algebra to algebra, and geometry to geometry, then that would solve the problem. Now I said up here that this was a completely randomized design. In other words, everybody's in a group, everybody has an equal chance of being in both either the online group or the classroom group. However, if you look carefully at the way these are divided, you'll see that I really kind of rigged this problem to do something specific, because notice there are exactly 5 pre-calculus students in the online group and in the classroom group, and exactly 3 algebra students in the online group and the classroom group, and exactly 2 geometries in the online group and in the classroom group. In a completely randomized design, that probably would not happen. But I wanted to have this set up so that we could move on to the comparison part. So if we were to compare these, what I want to do, if I think we go down to this next section, it says go back to your dot plots and use a color or symbol to indicate which course the student was taking for each of the dots. So if we go back and do that, we'll get this result. So I marked all of the pre-calculus students with a red triangle and all the algebra students with a blue square, and I left all the geometry students just the same with a black dot. Okay. So you'll see then, if we compare, you'll see now there is more of a distinct difference between the online group and the classroom group when we reduce the variability due to which class of math they were in. We see algebra compared to algebra, pre-calculus to pre-calculus, geometry to geometry. So this serves then to strengthen the evidence for the online course being a better course. Now if we take this one step farther, we'll see that the average improvement scores for the 3 classes vary based on the level of math. So the average improvement scores for the pre-calculus classes are 86, for the algebra 40, and for the geometry 20. And this includes both the online and the classroom groups, all averaged for each of the groups. So if we were to take each of the classes and see how much their improvement score differed from the class average, we would see another way of analyzing this data. So the X bar for the pre-calculus was 86. So for example, this was a 14-point improvement. The 90 was a 4-point improvement. The 70 was a 16% less than the average. Okay, so I shouldn't say a 14% improvement, a 14-point improvement, but 14 points bigger than average, whereas the classroom showed 16 or 6 points less than average. So if I continue doing that for each of them, I would get these results here. So see down here, this is what it would look like. So you would see here, looking at how different the algebra ones are from their average and the geometry ones are from this average, you would see that, notice all of the online course showed an above average improvement, whereas the classroom mostly showed a below average or zero improvement. If we were to plot all of these differences from the average, basically what we've done is rescale the data so that everybody is just compared with their own average, and you'll see this graph instead. Here's the average improvement for the online classes, and here's the improvement for the online classes based on their averages. So basically that we've removed the variation due to the level of math class. We're just seeing how much each of them varies above or below their average for their class. Now when we do this, now we get a much stronger evidence. We see a very distinct difference between the online class and the regular class because we have removed that excess variation due to a variable that affected the SAT score, which level of math they had taken. So this is going to lead us into another technique that we're going to use in an experimental design to help reduce variation.